Okay, so good morning students. So what we will do is I am making a series of videos. So I will be making probably a video on each concept on all the chapters which are there in the 12th NCERT syllabus. So the whole idea is if you go through these and if you work out the questions that I will be giving at the end of the class, it will help you master this particular concept as far as NCERT and NEET is concerned. So if you go through each one of them, I am sure it will help you for the NCERT exam. Plus those students who are appearing for the NEET exam, I am very sure this will help you a lot. Plus if you need more questions than what are being given here, you could reach us out to our number 98948997776 and we will send you more question papers. So right now in this particular video, I will explain to you what is Coulomb's law and I will explain to you all the nuances which are there in Coulomb's law. So according to Coulomb's law, F is equal to K Q1 Q2 by R squared. So you all must be knowing, you have already learnt in your classes saying that if there are two charges, suppose there are two charges here, let us call this Q1 and let us call this Q2 and let us say that they are separated by a distance R, then according to Coulomb's law, the force of attraction or repulsion between them will be equal to K Q1 Q2 by R squared, where R is the distance separating the two charges. Now K is a constant, that constant is equal to 1 by 4 pi epsilon naught. If I look at the values of K, K is 9 into 10 power 9 SI units and epsilon naught is 8.85 into 10 power minus 11 SI units. The first kind of question that I could ask you is I could ask you to convert or first find out the dimensions of these different quantities. So we can ask you to find out the dimensions of K, we can ask you to find out the dimensions of epsilon, both of these have come in the exam. Now as you all know that force is a vector quantity, so if force is a vector quantity, the force can also be represented as a vector. So here I have represented the force as a vector quantity. So here it is 1 by 4 by epsilon naught Q1 Q2 by R squared into I have multiplied it by R12 cap. So R12 cap is a unit vector which is going from 1 towards 2. Now there is not enough information whether this force is attractive or repulsive. So I am assuming that the force is in this direction. In this direction means it is an attractive force. So if it is an attractive force, these two must be opposite charged. So if they are oppositely charged and this is the attractive force, then this is going to be the force as a vector quantity. If they both have the same charges on it, that is identical charges, there will be a repulsive force, in which case the radius vector will not be along R1 to 2, it will be from R2 to 1 cap. Okay. So accordingly we can answer the question. Now here I have considered a unit vector. Now I need not consider a unit vector in all cases. So what I have rewritten it, I have rewritten this by not considering it to be a unit vector, in which case it will be 1 by 4 by epsilon naught Q1 Q2 by R cubed. Please note here it is R cubed and here is a vector R1 to 2. Now any vector can be written in form of its magnitude and a unit vector, in which case once I write this magnitude 1R will get cancelled here and we will get the same thing. How will this come in your exam? They will ask you which of the following expressions gives you Coulomb's law in vector form. So this will also give the answer, this will also give the answer. Now the complications could come up by they are asking you what is going to be the force on this charge. So if it is the force on this charge, assuming both are identical, then this will be a repulsive force. If it is a repulsive force, it will be in this direction, which is same as the radius vector which is going from 1 to 2. On the other hand, if these two are different opposite charges, then there will be an attractive force. If it is an attractive force, this R12 will change to R radius vector going from 2 to 1 and it is going to be a unit vector because I have R squared here, it will be a unit vector. Okay. So I hope this aspect is clear. Now you have already learned something very similar in gravitation, where you said that F is equal to G m1 m2 over R squared. Now that G that we had there is a universal gravitational constant. Even though the two formulas look the same, there is a big difference between them. The difference between them is one, G is independent of medium. That means the value of G will not change with the medium, but the value of K changes with medium, which means that the electrostatic forces are medium dependent. That means suppose I keep two charges in air, and if I keep two charges in water, the electrostatic force between them will be different, but the gravitational force between them will be the same. Okay. So, G is independent of the medium, that is number one. The second difference is M1 and M2 are always going to be like masses. We do not know anti-mass, we only know positive mass. Unlike that, in case of charge, Q1, Q2 could be like charges, or Q1, Q2 could be unlike charges, which means that gravitation is always an attractive force, but in case of electrostatics, the force could be attractive or repulsive. If Q1 and Q2 are identical, that means if they are the same charge, same type of charges, both are positive or both are negative, the force is repulsive. If they are opposite charges, then the force is attractive. Okay. So, I hope you understand this fundamental difference between gravitational force and electrostatic forces. Okay. So, I was explaining to you the difference between electrostatic force and gravitational force. So, if you look, both are inverse square law forces, that is electrostatic force depends upon the is inversely proportional to square of radius. Same way gravitational force also is inversely proportional to square of radius. So, both here it depends upon the product of masses, in gravitation it depends upon the product of masses, in electrostatic force it will depend on the product of charge. Now, understand one thing, that the K value I already told you is 9 into 10 power 9 SI units, while in case of gravitation the capital G is 6.67 into 10 power minus 11 SI units. So, here if you see, there is a big difference between them. While here you are multiplying it with a big number, here you are multiplying it with a very small number. That is why they say that electrostatic forces are much stronger than gravitational forces. Okay. So, understand that. Other than that, everything is going parallel in both of them. The differences I have already told, that electrostatic force is dependent on the medium, gravitational force is independent of the medium. Electrostatic force could be attractive or repulsive, gravitational force is always an attractive force. So, I hope this part all of you are able to understand. So, let us understand this. K is equal to 1 by 4 pi epsilon naught. So, this epsilon naught is called the permittivity of free space. Suppose you have this charges in some other medium, then I can say that K is equal to 1 by 4 pi ER into E naught. Okay. Here ER is called the relative permittivity. Okay, ER is called the relative permittivity. It is also represented as K, the dielectric constant, small k as the dielectric constant. Okay. So, to give you an example, dielectric constant of water is 80. So, what happens is that if in air the force between two charges, let us say hypothetically, is equal to 160 newtons, then in water the force between them will be equal to 160 divided by the relative permittivity or the dielectric constant, which is 80. So, it will only be equal to 2 newtons. Okay. So, please understand that whenever the charges are kept in some other medium, the electrostatic force between them will reduce. Why? Because every medium will have a dielectric constant greater than 1. For air we are assuming it to be 1, for vacuum also, for vacuum it is 1, for air we are assuming it to be equal to 1, which is almost like vacuum. Okay. So, this is what dielectric constant is. So, make sure that you are understanding dielectric constant. What kind of question you will get in your exam? They will say that there is a liquid which has a dielectric constant of, let us say 30. So, in air the force between two charges is, let us say 0.15 Newton. So, what will be the force when the two charges are dipped in that liquid? So, when the two charges are dipped in that liquid, the force will become 0.15 divided by the dielectric constant. Dielectric constant in this case we said was 30. So, it is 0.15 divided by 30, which will become, so it is 0.15 divided by 30, this will become 0.005 newtons. So, this is going to be the force. So, whenever the charges are put in any other medium other than air, the force between them will decrease. Okay. So, I hope you are able to understand. So, we were looking at Coulomb's law. So, F is equal to K Q1 Q2 by R squared. So, the kind of questions they will ask you is, suppose if we double R, that means if we increase the distance between the two charged particles to double, what will be the new force? So, if you are going to double R, it will become 2R the whole squared. So, 2R the whole squared means it will become F divided by 4. Okay. So, I hope you are able to understand. Similarly, if R is made half means you are bringing the charges together. So, if you closer together. So, if you are bringing the charges closer, then this R will become R by 2 the whole squared. So, R by 2 whole squared means the 4 value will go up and it will become 4 times F. I hope you are able to get this. The other kind of questions is, suppose you put this particular charges in a medium where the relative permittivity is 30, then what will happen to the force? So, very simply epsilon will come in the denominator. So, it will become the force in air divided by 30. So, remember the dielectric constant ER, which is also written as small k, is equal to the force between the charges in air divided by force in medium. Okay. So, if you remember this formula, then force in medium is equal to force in air divided by dielectric constant. Yeah. Now, the next question which has come many times is the dimensions of epsilon naught. What are the dimensions of permittivity? How to find out the dimensions of permittivity? So, whenever you get a question of this kind, you just catch hold of the formula and then you can work it out. Say for example, I can tell you that we are now saying that F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R squared. So, if you take epsilon naught up, F comes down. So, from there I can say that dimensionally epsilon naught will have the same dimensions as Q1 Q2 by F into R squared. So, Q1 is Q charge is ampere into time. Remember, Coulomb is not a fundamental dimension, ampere is a fundamental dimension. So, Q1 is ampere into time, Q2 is also ampere into time, F is ml t power minus 2, R squared is L squared. So, if I multiply all this and rearrange, I will get amplitude ampere square, I will get t power 4 t squared, and this will go up, it will become t power 4 m power minus 1 L power minus 3. So, the dimensions of permittivity will be a squared t power 4 m power minus 1 and L power minus 3. So, this will be the dimensions of permittivity. Okay. So, thank you. Yeah. So, I am explaining to you Coulomb's law. So, there we have seen what happens when there are two charges separated by a distance d, but sometimes what happens is there could be more than two charges also. So, what do we do in that case? In such a case, we will use the principle of superposition. What the principle of superposition says is, suppose there is one charge here, one charge here, one charge here, one charge here. Let us call this Q1, let us call this Q2, let us call this Q3 and let us call this Q4. So, if Q1, Q2, Q3, Q4 are there here, the net force on Q3 will be because of Q2, because of Q1 and because of Q3. That means, the force on Q4 will be because of force on 4 due to 1 plus the force on 4 due to 2 plus the force on 4 due to 3. This is what is known as the principle of superposition. Okay. So, this can come in your NCERT exam where they will ask you explain the principle of superposition. So, principle of superposition basically talks about when there are multiple charges present at in a region, the net force on any charge will be the vector sum of individual forces. Why vector sum? Because force is a vector quantity. So, because force is a vector quantity, I have put the vector symbol on them, only then it will work out. Okay. Now, the same question can come as an assertion reason question also. Say for example, they'll give you the assertion is, in case of multiple charges, the net force will be equal to sum of individual forces. The reason for that? The reason for that is charges act independent of presence of others. That means, the force between 2 and 4 will not depend on Q1, will not depend on Q3, it will depend only on Q2 and nothing else. The force between Q3 and Q4 will only depend on Q3 and Q4, it will not depend on Q1 and Q2. Okay. So, this is what we want to say, that charges act independent of the presence of other charges. This is an important property of charge. So, the assertion is in case of multiple charges, the net force is the sum of individual forces. The reason for that is forces act independent of the presence of other charges. That means the force between two charges is not influenced by the presence of other charges. Okay. So, I hope you are able to understand that. Just to give you an example, suppose there are 3 charges here. Okay. Suppose there are 3 charges here, 3 equal charges which are placed at the corners of a equilateral triangle. Let each of the sides of the triangle be equal to A. In that case, the net force acting on this charge, so charge Q1 is going to push it away, charge Q2 is again going to push it away. So, it will be the vector sum of these two forces. Okay. So, now because it is an equilateral triangle, this angle here is 60 degrees. So, if this angle here is 60 degrees, this angle also can be treated as 60 degrees, right. So, if these two are 60 degrees, then what I can do is I can add forces this way also. You have learned this in your 11th class in the case of vectors, that the resultant of two vectors will be equal to f1 squared plus f2 squared plus 2 times f1 f2 cos theta. So, in this case it will be equal to square root of k q squared upon a squared plus k q squared upon a squared plus this will become 2 times, I mean this whole squared plus 2 times k q squared upon a squared the whole squared. So, you have f1 squared plus f2 squared plus 2 f1 f2 cos theta. Now, theta here is 60 degrees, cos 60 degrees is 1 by 2. So, because cos 60 is 1 by 2, I put 1 by 2. So, I can cancel these two. So, now when I take root over of this, I will get root 3 kq squared by a squared. Okay. Alternatively, what I can do is, look, there is one force acting in this direction and this is the vertical direction. So, this angle here will be 30 degrees. So, the component of this will become f cos theta. So, there is one component f cos theta because of this force. There is another component f cos theta. So, the net force will be 2f cos theta, but now theta is 30 degrees. So, it will be 2 times kq squared by a squared cos 30, and we know cos 30 is root 3 by 2. So, the 2 will get cancelled and you will get root 3 kq squared by a squared. Okay. So, I hope you are able to understand this. Yeah. So, this is what is known as the principle of superposition. So, what we have discussed is, we have discussed what happens when two charges are separated by a distance. Then we have discussed what happens when you change the nature of the medium. Then we have discussed what happens if there are multiple charges. Okay. So, this is what is there in our NCERT syllabus. Only to this level you will get questions even in the NEET exam. Now, we can do this, we can increase the complications here and then we can look at other questions, but I think that will be beyond the scope of our exam. So, if you master this much, I think it is more than enough.